So if I consider a signal, the previous signal, some signal which is supposing like this, and let this signal be empty. Okay, if this signal is empty, in pulse code modulation that we have done in the previous lectures, so whatever samples we are taking, those samples, supposing this is TS, sampling duration, and what we do, we check the value of the sample, value of the message signal at that sampling instant, and then we approximate it to a level. Okay, then we approximate it to a level. We approximate it to some level which is this. Yeah, in this case it could be this. Okay, so at this particular instant, at supposing 0, then this is TS, 3 TS, 4 TS, so on. So at 0 or at TS 0, you approximate it to this level, and then we encode this level to be 101, or let this be 110, and this one be 111. Likewise, so at each level tells us about the complete amplitude of that sample in the duration. Okay, this is what we are saying. So if I check this 101, then 110, and 111. So this is a kind of a thing. So in this we need b bit of resolution. That means there will be L levels in this kind of a setup. In this kind of a setup, we need b bits resolution. B bits resolution. Okay, this is 2 to the power b is equals to L. That is L number of levels. Okay, L number of levels. So yeah, so in here the trouble is that if we only, so there are L levels, and we have seen that if the signal is more concentrated towards lower amplitude level rather than the higher amplitude level, then we can use companders to cope up with that. Okay, to cope up with that. But what we see in here is that even though the amplitude levels, the three respective levels that are shown in here, which is this one and this and this. So this encoding is done for the complete three levels. So instead of doing the encoding for the complete amplitude level, what we can do, one can do is one can just do the difference. One can just do the difference in the amplitude. If you only, because we are at time instant TS, at time instant 0, the amplitude level is this. The amplitude level will be, let's say this is A1. Amplitude level be A1, and then it is A2, and then this is A3, which is encoded as 101, this, and this. Yeah, and this. Okay, so these are the amplitude levels that are encoded to these values. So if I actually see, what is happening is that from 0 to TS to 3 TS, the difference in the amplitude level is very small. Okay, however, the amplitude level itself, that is A1, A2, and A3, are larger. So we have to encode it, we have to encode these. So if somehow we only encode the difference in the amplitude, respective amplitude levels, then we can have lesser number of levels. Okay, then we can have lesser number of levels. Okay, lesser number of levels means less number of bits to be used for transmission. So what we are saying is, instead of quantizing the samples of the message signal, okay, what we can do, we can quantize the difference between the successive samples. So if this is sample mk and this is mk plus 1 and this be mk plus 2. Okay, so what we want to do is, we want to quantize the samples. Instead of quantizing the samples, let me write it. Let me just write it here. So instead of quantizing the samples, of the message signal, one can quantize the difference. One can quantize the difference between successive samples. Okay, so why? Because what is the motivation? The motivation is because the difference is smaller than the original amplitudes. If the difference is smaller, then in that case, even with less number of levels, we can easily represent it with finer granularity. Okay, so we can have finer details. We can have finer details. So this is because the difference is small. Okay, as the difference is small. So by doing this, what we can do is, we can have, for the same resolution, that means number of levels, if the dynamic range is signal is small. Okay, if we only have to encode this differences, that means this or this. Okay, then for the same resolution, that means if I have the resolution of b bits, for the same resolutions, the dynamic range is of the signal becomes smaller. Okay, that means the dynamic range of the difference of the signal is smaller. So that eventually says, for same resolution, or level L, the dynamic range of the different signal is small. Okay, so if the dynamic range is small, then in that case quantization step size will be small, and if the quantization step size is small, then it eventually says the quantization error will be small. So then this leads to quantization step size. So resolution level, dynamic range of the signal is small. Therefore, the quantization step size, which was, we have denoted this thing by del V, is small, where we have given this thing by 2 MP by L, and then, which is 2 MP by L. This, if the step size is small, then in that case we can say that the quantization error, that also will be small. That means the quantization error, which was del V square by 12, is small. Okay, So the quantization error will be small. So is this thing convincing or not? First of all, before I proceed further, I wanted to make this thing clear. Is this thing clear to everyone?
So I have a doubt.
Yes, go ahead.
So I did not understand the concept of del V being small because so even in the previous case, what if we
Mhm.
took finer levels? So even in that case, del V will be small and quantization error will be small. So then if we take the level, I mean, if we take the finer quantization levels, then what is the need of doing this different stuff?
I never said to take the final quantization levels. I said now what we are doing is instead of encoding the complete amplitude, we are only encoding the difference between the amplitude. So
No, so I'm asking, what if we take final levels? What if we
mhm.
take final levels? So is there a need to do the difference in levels as well? Will there be a need to do this then?
If you are taking final levels, what are you gaining and what are you losing? The thing that you are gaining is you will have less quantization error, but what you are losing is the overhead. That means, sorry, not the overhead, the number of bits, the number of bit sequence that is being produced will be larger. That means to represent the same information sequence, you are going to have larger number of bits. Yes or no?
Yes, sir.
So which you don't want, because you want the communication, you want the your information to be represented in minimum number of bits. So the question in here what we are posing is, can we with the same level, with the same resolution, can we have a better or a lesser quantization noise, or even with lesser or even with a lesser resolution, can we have a better or lower quantization noise? The question is this. So that is agreed that if we have more number of quantization levels, in that case, this del v, that is the difference or the levels, will increase, or del v will become smaller, and then this will result into smaller quantization error. Okay, so that is fine. But in this method, the problem is that, what is the problem? That we will have
Higher number of bits for storing the
higher
data.
number of bits. Yeah. So, but instead of encoding this, yeah, instead of encoding this complete level, which is from, which represents this level, we only encode this portion. If we can only encode the difference, somehow if we are able to do this, then in that case, the same, because the range itself is small which is to be encoded. Okay, the range itself is small which is to be encoded. So in that case, what will happen is that the so with the same resolution you can have very fine levels, or you can reduce the resolution to have coarser levels. But what will happen in the overall strategy of this delta modulation, that the number of bits that are needed to represent this signal will be drastically reduced. Okay.
Yes, sir.
Yeah, so let us do it once, let us go ahead and do this thing once, and then it will make more sense that how exactly it reduces the representation of the complete signal in number of bits. Okay, how it actually does. So for that, let us assume we have set this mn. Let us say this mn be, let us say this mn is the sample of the message signal mt at time. This is the sample of the message signal mt at time n. Okay, and let us say mqn minus 1 be the quantized approximation of mn at time n. Yeah, be the quantized approximation of mn at time n. Okay, let us say this. So we are going to do three-step process where the step one will be finding the difference between the successive samples. Okay, so step one would be step one is finding dn, which is dn is the difference, that is finding the difference, okay, which is given by defined as dn is equals to mn minus mq n minus 1. Mq n minus 1, that is difference or the error. This is the difference for the error. Then we do step 2, that is again quantizing the difference. Quantize the difference. This is and this is nothing but we have this dqn quantizing the difference, and that is again del by del of sine of dn. Whatever dn we have calculated, we are going to multiply it by the step size del and then multiply it by the signum function. And we all know what is sine of what is sine of x. How do we define this thing? Anyone? How do we define sgn of x? That is, it is 1 if
If
x
x is
is
more
greater.
than 0, then it is 1,
Yes.
or else it is 0.
Yeah, but at 0 it is 0 and it is minus 1 for
Minus 1,
x
sorry.
less than 0. Yeah, correct. So we are just going to simply use this definition. So collectively, if I see what is this value of dqn, this dqn is, so I'm going to leave this one point which is at 0. I will include that in one of the conditions. So what I'm going to say in here is that it is going to be either del or minus del, okay, depending on if dn is greater than 0 or if dn is less than 0. Okay, based on that. So then in that case, dqn can take two values, which is either minus del or plus del. Okay, so what is actually happening is, because there are only two levels, okay, so then how many bits do we need to encode this? So either it's going to, at every stage we are encoding this thing as plus del or minus del, so there are only two levels. So how many bits do we need to encode this?
One.
Yes, or it can be encoded using a bit. Okay, so then the resolution is, so it has got 1 bit, one bit resolution. So and the step 3 would be, step 3 is again reconstruction. Step 3 is reconstruction, that is again we are going to assign this mq n as mq n minus 1 plus dq n. Okay, so These are the three steps that we follow. So then we do reconstruct prediction or approximation for the next time instant. So at this stage, this is still not clear that how exactly delta modulation is functioning by these three steps. Let us take an example and then try to understand this. So what it does in here is, let me just give the essence. The essence is, the first stage we obtain the difference between mn and mqn minus 1, and as we obtain the difference, we see whether this is greater than or less than 0. If this is greater than 0, then this dqn is assigned as plus delta, or it is assigned as minus delta, the difference. And then once has been assigned, then the next sample instant, that is mqn. So mqn is, you remember this, we are taking the difference between the original sample mn and mqn. So then mqn is further assigned as the previous value plus that dqn, that is either it's going to be plus delta or the minus delta. Yeah. So let us take this example. Let us take an example and then try to understand this. Okay. Yeah. Let us consider an example of the signal. Let us say the signal goes like this. Okay. Let us say the signal is like this, and we have interval n like these, and let this be n minus 1, n plus 1, n plus 2, and so on and so forth. So, and assume that, so, and we have to assume a size delta. We have to assume a step size delta. Okay, let it be like this only. Yes. So at a given time instant, if I see what will happen is that we are going to calculate these three steps. We will keep on doing these three steps iteratively, and then see what it results into. So at the step one is calculating the difference. The difference, that is, okay, let us write the three steps so that we don't have to go over again and again. I mean, we don't have to scroll this thing. So dn is equal to mn minus, so step one, I will just write in here, dn is equals to mn minus mqn minus 1, and then we have dqn, which is del of signum of dn. Okay, and then we had the final step, which is assignment step. mqn is equals to the previous step n minus 1 plus whatever we have obtained in the dqn. 1 2 and
Sir,
yeah, go
what
ahead.
is the meaning of DQN?
So dqn is saying that whether the difference was positive or the difference was negative. That means whether the new signal which has come, has increased or it has decreased. Srishti?
Okay, so yes, sir.
Yes, this is what it says. So let us see an example. Let us construct this example. In this example, let us construct this and then see. Let us see this. Let us see this. So if I check this at instant n, okay, if I check this at instant n, so the first step is obtaining the difference between mn and mqn minus 1. Okay, so mn is this, mn is this value, mn is this value, and let us say that mqn, the previous level, would be like this. We are not going to take the exact level. We are not going to take this point. Mqn will be what? Mqn is the if I go back, MQN would be the quantized approximation of Mn. Okay, is the quantized approximation of the Mn. So it is not going to be exactly Mn. So let us say that this was MQN, this level was MQN, and if we see that this difference dn is what is positive, then what is dqn? So let us write this. Let us write this. Let us say this is dn and dqn, and then we have mqn. So dqn at this stage for t is equals to n, okay, for t is equal to n, uh, dn is mn minus mqn. And what is dqn? Dqn is positive in here. If dqn is positive, then it will have the, what is the value of dqn? What is the value of dqn? If I see equation number 2, so it will be del sgn signum of dn, and if dn is positive, then this dqn will result into,
Del.
Like one.
it will result into del, yeah, whatever is the step size, okay, it will result into del. So now assuming that the step size is this, let us say that this is the step size del. If this is the step size del, then in that case what is mqn? Mqn is nothing but the previous value of mqn minus 1 plus dqn. So the previous value was this, the previous level was this of this mq n minus 1, and now the new value of mqn will be what? Will be an increment by the step size del. Yes or no? Is this thing making sense? Now the current value would be this, whatever is the del size. So let us say like this, yeah. Yes or no? Are people able to follow what I'm saying? So it will be like this. This would be the value. So this would be the value. So it has gone. So now this, if I see the equivalent message signal, that is mqn has altogether obtained from this value to this value, from the level, let us say a1. Okay, we have assumed this to be del, so let us say this is del again, be, yeah, this value which is a2, and similarly let us say this is a3, like this, and then say this is a4. Okay, so we have gone from this value to this value. Now what will happen at t is equal to n plus 1? At t is equals to n plus 1, and mqn is positive, so the level of mqn in here becomes a2, and dn was the difference mn minus mqn minus 1. Yeah, so that is altogether, yeah, fine. Yes, so what do we see in here? What do we see in here? So that is del. Okay, sgn of this is del. Now at t is equal to n plus 1, what will happen? We are going to calculate dn, okay, but at n plus 1 we will be doing dn plus 1, is it or not? So what is that value? dn plus 1. dn plus 1, so this is the value which we are considering at t is equal to n plus 1, which is this. So what, so dn plus 1, this expression if I check, so then this, okay, let me just write these things so that this becomes easier. Mn n minus 1. So at d, so d n plus 1, what is this value? What is dn plus 1? Dn plus 1 is defined as mn plus 1 minus mqn. Yes or no? Is this thing clear to everyone? Everyone? Aditya, Akash, Pujita,
Yes, sir.
Abhigya.
Yes, sir.
Yes, sir.
How about other people? So can anyone tell me that what is this value of dn plus 1, whether dn plus 1 is positive or negative? So we know what is mn plus 1. Mn plus 1 is this value. So mn plus 1 is this value, which is this, and let us say that this is a3. Yeah, and we know what is mqn. What is mqn? mqn is level a2. mqn is a2, level a2, this level which is this level. So in that sense, what is dqn? So well, will this dn be positive or negative? Will this dn be positive or negative?
Positive.
Positive.
That is again positive. If this is
Positive.
positive, yeah, if this is positive, then what will be dqn? Dqn will be equal to
Del.
again del. If dqn is equals to del, then what is the value of mqn plus 1? What is the value of mqn plus 1? That is nothing but the previous level plus dqn, and dqn was positive. So what will happen in here is that this will again, the final level of mqn will be what? Will be incremented by the del size, and now the final level will be a3. Is it or not? So this becomes a3, amplitude level a3. So this will rise up to a3 like this, and it will like remain like this one. Yes or no? Is this thing correct?
Sir, it will
Sir,
be
so
just
this,
above 80, right?
It will
Because
be
you
just
have taken
above.
A3, because you have taken approximate value in A1.
Approximate value in a1. Can you repeat your question? I'm still unable to get the question that you are asking.
I'm
Srishti.
saying that A3 level, uh, it is above Mn plus 1,
Above the, yes, above the value of the signal which takes at, that is above m,
N plus
above
1.
this m of n plus 1. You are saying that
Yes, sir.
this is mn, sorry, mt, this is mt, but this point in here in green, this is
Yeah.
m
Mn plus 1.
n plus 1, where mn plus 1 is more than, which is less than a3.
Yes, sir.
Yeah, mn plus 1 has got nothing to do with mqn, because mqn can only take integer multiples of del. Is it or not?
Yes, sir.
Mqn can only take some integer multiples of, so this is del, this is again del. So a1, a2, a3, and a4, these all are dels. Difference between them is del. Yes or no? So this del, or the step size, we have fixed it. This is what we are doing is for a given step size.
Okay, sir.
Shrishti, is that thing making sense? So
Yes, sir.
these two are two different levels. Evaluated, the signal mt evaluated at point n plus 1 versus a3. These are two different levels. They can be same also, but in this case, these are two different levels.
Yes, sir. Okay. Yeah.
Okay. Yeah.
Sir,
So
sir,
yes, go ahead.
sir, so in this case, the positive and the negative thing. So this is specific to this empty, right? So if I have an empty which is kind of sinusoidal, and if I am trying to do something with the negative portion of that, so
Mhm.
in that case, dn plus one will be negative, right?
We are going to come on to that. We will continue this thing to larger value, and then we see what happens. What happens? Okay.
Okay, sir.
Yeah. So is this thing till this point? It isn't making sense.
Yes,
sir,
sir.
sir.
Yes, Akash. Go ahead.
How can we make sure that the difference between A2 and A1 and A3 and A2 are same? Like it depends on the curve. No?
No, A1 and A2 and A3, A4, we have just fixed it by supposing I have a del size. some del size. Okay, and then the relation that I'm saying is that a1 is nothing but, sorry, a2 is nothing but del plus a1, and a3 is nothing but, sorry, del plus a2. So what I'm saying is the difference between a1, a2, a3 and a4 are del, and for a given fixed del, that means a given step size, we have these levels a1, a2, a3, a4.
Okay, okay, sir. Means this is our assumption, right?
For a given step size, this is what we were saying. Now this is what we are saying.
Okay, okay, sir. I got
Yeah.
it.
So in this way, I can partition the complete region into like these delts and say that these are again, all of them are, the differences are del only.
Sir,
Yes, go ahead.
sir, when we are calculating the first step dn,
Uh-huh.
so mqn minus 1 can be greater than mn even if mn minus 1 is less than mn. So is it possible?
Yes.
So,
MQ, we are going, just going to see now. We will just see now. Let's wait, let's do this thing till this point. You yourself will have all the, these all combinations will come. That's why I want to do this thing further for 4 5 more steps. What you are saying can happen.
okay, sir.
Who was this? Abhishek.
Yes, sir.
Okay, yeah. Let's do this thing further. Let's do this thing further. So now if I want to do this thing again for time instant t is equal to n plus 2, what will happen in here? Sorry, for n plus 2, what will be the value of dn plus 2? What should be the value of dn plus 2? What is the value of dn plus 2? So if I check, dn plus 2 will be what? M n plus 2 minus mq n plus 1. And mqn plus 1 is level A3, and mn plus 2 is what? Mn plus 2 is this point, again in this green, this point. That is empty evaluated at point n plus 2. So what is this? What is the difference? Is the difference positive or the negative?
Positive.
Is positive. This is positive. So in that case, the value of dq, the value of dq will be again del. And what is the value of mq n plus 2? What is this value? What is this value? If I go back in here, what is this value? If this is positive, then mqn can only have increment or decrement of del. So what is this value? Mqn plus 2.
A4.
It becomes A4. It becomes A4. And let's say that A4 level is this. So in that case, this becomes like this value. This becomes A4. Now, the next step, if I consider this thing to n is equals to t is equal to n plus 3, then what is dn plus 3? If I check this, let me just zoom out so that you can see the plot as well as what we are writing. Yeah, yes. Now if I check this, what is dn plus 3? Dn plus 3 is m n plus 3 minus mqn plus 2. And what is this value? Is it positive or negative? So mn plus 3 is this value in green. Okay, this value in green. Sorry, not this. Mn plus 3 is this value. This is n plus 3. So this is m of n plus 3. Yes, and if I consider this, compare this with mqn plus 2, mqn plus 2 is this. What can we say? Is it positive or negative?
Negative.
So what can we say about dn plus 3? That is negative. If this is negative, then this value of dqn, what is that? What is dqn?
Minus del.
Dqn becomes minus del. If this dqn becomes minus del, then what is this value of mqn plus 3? Mqn plus 3 will be mq, this will be mq n plus 2 minus, sorry, it was plus of dq n plus 3, and dq n plus 3 is nothing but minus del. So then this becomes mqn plus 2 minus del, and what is this value?
A3.
This becomes a3. This becomes a3. That means our mqn plus 3 would be a3 at this level, will be at this level. So it is going to come down to this level, okay, and then will continue like this. Is it or not? So what will happen at this point? Again, let us say that this point is this. There is, yeah, what will happen at the next point? If I again happen to see this, let us check this. So at t is equal to n plus 4, what is dn plus 4? What is this value? Is it positive or negative? It is again the difference between mn. So mt evaluated at t is equal to n plus 3, which is this value, okay, which is this value, and which is slightly less than a3, subtracted by the previous value. It takes the quantized level, that is mqn plus 3. So what is this value? Is it positive or negative? Is it positive or negative? Everyone,
Negative.
it is negative. If this is negative, then in that case this dqn is negative, and then this mqn plus 4, what is this value? What level it takes? If this is negative, it is going to have a decrement with del. That means a3 was the original, was the previous level, so a3 minus del will result into
A2.
a2. So then this will lead to, this level, and it will come on like this, okay, it will come on like this. But n plus 4, and this is n plus 5. So what will happen at n plus 5? Can people tell me directly now what will happen at n plus 5? If I check this point, if I, so what we are comparing, the value which the signal mt takes, and the level at that point. So what is this? Is this difference is again positive? Yes or no?
Yes, sir.
At n plus 5, at t is equal to n plus 5, this difference is positive. So this becomes del, and this should become a2 plus del, and that will be a3. So now this goes to a3, like this, and so on and so forth. It will continue, and at this point again the difference would be, if I consider this point like this, so again the difference would be small, so it will come down and it will go ahead further. Yeah. So are these, is this clear to everyone or not, what we have just now done?
Sir, so all these depends on the value of delta and our message signal, right?
Yes, correct.
Whether it is minus delta or plus delta.
So that altogether depends on the difference between the previous quantized level and the present message signal.
Yes,
Previous
sir.
quantized level and the present message signal. This, if you check this, so this and this. So the quantization which was done for the previous amplitude level and the present amplitude level. That means again, if you roughly see, that is a difference between the two successive levels, whether that is greater than the step size or less than step size. Now, is this thing clear, Srishti?
Sir, one more
Yes, sir.
thing. why we didn't consider the case of difference to be zero? Like,
Why did we didn't consider the difference to be zero? Because zero can be taken either in positive or in negative. That means it can say that, because you actually, if you see in computers, you will not get an absolute zero. Okay, you will not get an absolute zero, and even if you get one, you can include this in one of the possibility. I can always say it like this: greater than equal to zero in one case and less than zero.
okay, okay, sir, I didn't see that equal to sign. That's why
No,
I
I
asked.
just now made the equal to sign. There
Okay,
was no equal to sign.
okay, sir.
Yeah, I just now made it. I'm saying we can just include this single tiny point in any of the condition. That altogether tells uh, that this is the way in which we can define always, and then get rid of the single point zero. Okay. Yeah. So now if this, in this, we knew that if this is plus del, okay, or minus del, in here we said this. There were two levels. Okay, there were two levels. That's why you are using a bit, 1 bit resolution. We are using 1 bit resolution. So in that case, let us see what will be the encoded output. Okay, what will be the encoded output? So if this is plus del, if this comes out to be plus del, then we encode this thing to plus 1. Okay, then we encode this thing to plus 1. Okay, and if this is equal to minus del, then we encode this thing to 0. We can encode this thing to 0. So whenever this is 1, this is 1, this is 1, this is 0, okay, so on and so forth, this is 0 and this is 1. So whenever there is an increment whenever there is an increment in the level, we encode this thing as 1. Increment is encoded as 1. So this is what we are doing. So we had 3 ones and then 0. So that means at each of n plus 1, n plus 2, there were increments. So that's why these are encoded as 1 1 1. And at point n plus 3, there is a decrement. So this is encoded as 0. And n plus 4 as well, there is a decrement. It is encoded as 0. Then this is again 1, and then it will be 0. So if I check this at every time instant, how many bits are we producing at every sampling instant? At every sampling instant, so the sequence that I'm getting is 1 1 1 0 0 1 0, like this. So at every time instant, or at every sampling instant, that is n plus 1, n plus 2, n plus 3, how many bits are we getting? How many bits are we producing? How many bits are we producing?
One.
We are producing only 1 bit. Okay, so if this is ts, so at every sampling duration we are only producing 1 bit. So that means 1 bit per oh, yeah, so it got unshared. Yes, so at every instant, every sampling instant, how many bits are we producing? It's 1 bit. So what do you remember? What were we doing in the previous case? What were we doing in the previous case? How many bits were we producing? Do people recollect what were we doing in PCM? Every sampling instant, the example that you have constructed. Yes, Shrishti, you were saying something.
So 3 bits.
3 bits. If we had 8 levels, okay, if we had 8 levels, even then we were producing 3 bits. And if we had 16 levels, then we were producing 4 bits per sample. In here, I can always change the size delta, but even then, at every time instant, every sampling instant, it will produce 1 bit only. Okay, it will produce 1 bit only. So are these steps clear to everyone? What we have just now done, is this clear to everyone?
Yes, sir.
So yeah, so do you see the benefit of using delta modulation over PCM? Do you see the do you see the advantage of using delta modulation?
Yes, sir.
Yeah, so now if in a special case, so if in the special case, if I change this delta, okay, if I change this del, so this del size, but there are still some problems also associated with the delta modulation. The problem is if the signal is changing very steep, okay, if the signal is changing very fast, that means if the signal is like this, if this signal is changing steep, supposing like this, and we have the step size like this only, if the step sizes are like this, so then the quantized signal will not be able to match the change in the will not be able to match the change in the message signal, will not be able to match the changes in the message signal. So if these are the sampling intervals, and supposing we were starting at this level, this, so for this, so at n plus 1, n plus 2, n plus 3, so for n, so in here if the quantization level was this, okay, so it will increase and then it will decrease like this, continue till this point, and then this will decrease, but it will go like this, then decrease, it will go like this, then decrease. Okay, so what is happening in here is that there is a huge difference, there is a huge difference, is it or not? There is a huge difference. Or if the step size are even smaller, if I say in the same signal, if the step size are even smaller, let us consider the same example with twice the level of the step size, with reducing the step size to half at the same sampling intervals. Okay, if I now, instead of saying this, let us say the step size is half of this. If the step size is half of this, now what will happen? So at this time, at this stage, at time t is equal to n, we had this level as in the previous case, this level. But at time t is equal to n plus 1, it will increment to this value and remain it like this. Now we see the difference is negative, so there will be a minus del like this. Okay, and it will continue till this level, and then it will come down to this level like this, and then this will again, it cannot come so sharply, it cannot come so sharply because the step size is small. Okay, so it will go like this, so which is way more deviated from the original signal. So this is again, the difference might be very not very close to the message signal. In the first case, case 1, it is even then closer, but case 2 is very further apart. So there is a problem with the delta modulation. Okay, based on that, so what we can do, we can say that the step size can be differential. Okay, so based on that, we can say that the step size, this can be adaptive. Okay, the step size can be adaptive. Okay, so if this is adaptive, then this is called as adaptive delta modulation. Okay, so there are various variants of this delta modulation. So it is adaptive, it can be adaptive, this is called as adaptive delta modulation, or pulse code modulation. There is a similarity between pulse code modulation and delta modulation. Let's talk this thing in the next lecture, we are already short of time. Let's stop at this point.